What an honor to be with this international group. I'm truly astounded at how cool this is. COVID has been really disruptive. One of the best parts is how globally connected it's been. I've been reading the chat window scroll by, and the amount of locations and cities dialing in, and people I know and love dialing in. It's phenomenal. I'll do my very best to provide something interesting, thought-provoking, potentially even inspiring, and high utility. Oh, and I saw a child hoisted through someone's video chat. Pets and children are always invited in everything that I do, and I hope for all of us. What I would like to share is what I learned about Agile hardware. A lot of us here are Agilists. We love the idea of short deliveries and testing something with a real customer and learning what to do next cheaply. And in software, we can delete the previous version or deploy right on top of it. In hardware, how do you embrace agility? Well, I've spent the last 14 years exploring that, 15 years now, exploring that. And I'd like to share what I've learned to date. And that's not what I meant to do. I meant to do that. In 2006, I founded a road legal automotive manufacturing company. At that point, I was then legally allowed to produce stuff that you could put a license plate on and drive on the road in the United States and eventually in Canada and Europe. One of these cars is now in Germany, and 3 in Canada, and all the rest are in the United States. Although I've heard other people using the open source plans have at least started building them in many other countries. I don't know if there's other operating cars in other countries. That's one of the beauties of open sourcing something. It grows past your awareness. We ultimately produced 14 road legal cars, not a world-changing number. What we did prove is you could design, analyze, build, test, deploy road legal cars in less than a week. We set 4 world records doing it, and that then earned me the opportunity to work with Toyota, BMW, Volkswagen Group, including Porsche and MAN Truck and Bus, Nissan, and eventually Tesla, which I'll talk about shortly. In 2012, we became the first automotive manufacturing company to accept a digital currency, and it was Bitcoin. Now, Bitcoin was worth about $8 US at the time. Bitcoin has its highs and lows, passing $60,000 US recently. So it turned out to be a really good idea for us to be very open-minded about digital currency. And what I'd like to say here is the Agile mindset of making it cheap to change your mind, embracing uncertainty for the customer's advantage, has treated us well. So I'd recommend, how to say this. When Tesla bought $1.5 billion US worth of Bitcoins recently, an immediate question I had was, will BMW do that? Will Toyota do that? Will Ford do that? And of course, none of them did. And you can see immediately where there are agile change agents in leadership capacities. And you can see immediately where the product roadmap is willing to be disruptive. So maybe it's a litmus test for awesome. In 2020, I joined Tesla. I joined the global headquarters in Fremont, California, where I operated Agile at Tesla as a program. I worked in collaboration with Lean at Tesla, and my job was to reduce the cost to make change, to make it even faster and cheaper to do what we call new product introduction and new product development. How do you build cars like you build apps? When you want to make a change to an app, you tie into your automated tests and your automated deployment and your continuous integration and your continuous deployment. How do you do that in hardware? And that was my job. Now, Tesla was already having phenomenal successes with that. When I joined, Tesla was already making 27 updates in hardware per model per week. A hardware change for a car is a 4-year project for most manufacturers. There's waterfall phases to verify you have the correct suppliers in queue, the suppliers can deliver at the price you want, you're ready to receive, you can inspect the goods, you can process them appropriately, you can store them appropriately. You can then add value to them in a sequence of steps. The factory is configured, the staff is trained, the support staff of the staff are trained, and you can begin production. That sounds like waterfall, right? So what would it mean to do Agile in hardware? It sure looks like this Agile thing is financially viable. Tesla now is worth more than every other car company added together. And if we overlap that over how quickly Tesla introduces new product change, it looks like there's a correlation. Toyota is 2.5 to 4 years to do what's called a minor model change, changing the way the front bumper is shaped and the navigation software, for example. And their total company value at my last count was $210 billion US total market cap, versus Tesla at more than 800 billion total market cap, depending. This fluctuates widely based on the day. Volkswagen and BMW and Daimler added together worth about 181 billion US. Again, a little slower minor model change, closer to the 4-year mark. And GM plus Ford plus Fiat Chrysler, now Stellantis, worth a little less and a little slower. And the executives seem to understand this. The executives of all of these companies seem to want us as Agilists to help increase the speed of new product release. Volkmar Denner at Bosch announced all 300,000 people at Bosch should embrace agility so they can release product faster. Akio Toyoda, CEO of Toyota, and my client, same thing, says the chief executive officer's job is to fuel change at the point where the work is done. Herbert Diess, a force for amazing in Volkswagen. The question is, can Volkswagen as a company embrace agility to meet Herbert Diess' vision? Says exactly that. The big question is, are we fast enough? If we continue at our current speed, it's going to be very tough. And Elon Musk, my CEO, says, pace of innovation is all that matters in the long run. And it's not just talk in a company like Tesla. What I learned when I was working with Bill Gates, I was a developer at Microsoft before in software, and then a Scrum Master at the Bill and Melinda Gates Foundation, where I did work directly with Bill Gates. And Bill Gates started every single meeting with, how much of this can we do in parallel? That stuck with me. Bill tried to teach all of us a lot of things. I was able to learn this at the time, and that is object-oriented architecture. For us, many of us with an Agile software development background, the idea of parallel executable work, multi-threaded work, is object-oriented architecture. Microservices, MSOA, how to do that with vaccine deployment was part of my work at the Bill and Melinda Gates Foundation, working with Rotary International to help eradicate rotavirus and reduce polio. I took this idea to hardware and splitting hardware projects into parallel executable chunks. And it ends up looking almost exactly what Henrik Nieberg showed us the Spotify model was at that time. And yes, I know Henrik says, don't call it a model. It's just what Spotify was doing at that time. And they continue to learn and they're very different now, maybe even much better. All of that may be true. But when I've been doing agility in hardware, it looks a lot like what Henrik Nieberg said the Spotify was doing at the time. A car, to design, build, test, deploy an entire road legal car is a 5-year project or a 7-year project, depending on its complexity. So how do you get 27 changes in a week? Well, first you cut it in half and put a known stable interface so teams can iterate those two halves completely independently. And as long as the interfaces plug in together, it'll still work. So now you have a 2.5 and a 2.5-year project. When you cut it in half again, and you cut it in half again, and now you have 8-month projects. Well, how do you get from 8 months to about once every 3 hours? Well, that's all the cool agility that the Agile coaches in this conference know about. That's your shared ownership practice, so you can have round-the-clock development. That's your continuous integration and continuous deployment. So while we're drawing 3D models, There's continuous feedback on crash simulation as you're drawing, just like code complete. As you edit procurement spreadsheets, you get real-time price data adjustments of the total bill of materials. It's all about speed of feedback loop, which reduces cost to change. Paul Tacken in the Netherlands is my best friend. And Paul Tacken is the head Agile coach, if there is such a hierarchical title, for ING Bank in the Netherlands. And I learned a lot visiting ING Bank and continuing to talk to Paul. And deployment of parallel executable chunks really does seem to be the entire name of the game, and trying to do that with as little hierarchy as possible. In hardware, I will brazenly call this the Wikispeed model. I will brazenly say that this shapes the way the company is structured. If the company is structured around these cross-functional teams that each execute a parallel executable chunk of the hardware, that is your company structure. You don't need any other hierarchy. Where I worked in Tesla is where Elon Musk often slept. Elon Musk has a set of videos that he's put in his Twitter feed and on YouTube with Marcus Brownlee saying, here's where I sleep in a sleeping bag. And that's right by where I spent a lot of my time, about 3 meters away, actually. And that's how fast large decisions are made in a company like Tesla. I never had to make a report to say I need to spend a lot of money buying robots or buying land or building a new factory, ever. Because Elon Musk and everyone else in the so-called hierarchy, there really is no hierarchy, it is completely flat, is working right there all the time. There are no offices, there aren't desks, there are almost no chairs, and everyone works the line. You work cars, everyone. Elon puts car parts together when he's not at SpaceX or Boring Company or Neuralink, everyone does. There are no thought-only jobs. Oh, there's plenty of software. There's laptops on the floor, all that. But you are also configuring robots and lifting 20 kilograms and putting them places, everyone. So if anyone needs to justify expense, or well, you don't really have to justify anything, you're empowered. But if anyone decides to make a large capital move, you turn to the people around you and say, is this a good idea or not? And people say yes or no, and you're handed a credit card and you go. Because they're right there. And I think this is what a lot of our clients don't feel comfortable with yet. I can't yet imagine the board of Daimler working the line and building cars. I don't think they'd want to. So you have a cultural gap between this leadership caste that wants to dress a certain way and talk a certain way and eat a certain way and use a really clean bathroom, and then a caste that's been told you don't get to use a clean bathroom and you should dress a different way and you should talk a different way. And we wonder why flat organizations or other aspects of agility are resisted. And you end up getting these weird agile scaling models that build hierarchy again, which obviously slows the company down because by definition, that's a slower feedback loop. Anyone who's ever done recursive programming or programmed a fractal is familiar with that. So how does this work? There are teams that each build a module and they work completely independently. So shared services are things like coffee service to make sure everyone has delicious coffee, and internet service to make sure everyone has super fast internet. So shared services that have a service level agreement that meet everyone's lack of frustration, those are central functions, right? But then you have people that work on the heat pump, for example. Well, that's a team, and they need to do their own procurement. If they waited on a procurement department, it'd be too slow. And Mirko Kleiner's brilliant work with Lean Agile procurement helps enable that in all companies. Then they do their own software testing, their own hardware testing, their own software development. They do their own test fixtures and manufacturing. They have to, so they're not waiting on each other. I mean, parallel execution. It's what Bill Gates was trying to teach me back in 2008. And the Musk companies actually do it. This is what I call Justice's Law. when you have a lack of shared services and you have fully contained module teams that can execute in parallel. Now, your biggest risk is integration risk. Will all these modules work when you stick them together? So I recommend the truism, if something is difficult, do it all the time. So of course we do continuous integration, and that's roboticized as often as possible. If you watch any of the YouTube videos of Tesla or SpaceX manufacturing, what you often see are robots moving. They don't show you the swarms of people. There's tens of thousands of people, but robots make good video. What those robots are usually doing is testing, do the modules fit together? And if they are, those ship, those are deployed. I had an opportunity to work with the leadership team at Amazon, and Jeff Bezos was very strict about small team size. Never even have a meeting where 2 pizzas couldn't feed the entire group. And these are pretty big pizzas, but still that ends up meaning 6, maybe 9 people, maybe. And that seems to be completely true at Tesla. One of the reasons that appears to be true is if there's a disagreement and there's more than 6 people in the conversation, either everyone checks out and they refer to someone to try to elect a leader just to decide, so people don't have to consume their calories mentally trying to engage in a group conversation. And that creates a leader dynamic, which by definition is slow and less innovative. Or you get heated arguments and the conversation doesn't end in a reasonable amount of time. With an issue of contention, to come to a collaborative conclusion where you have group buy-in, you want 6 or less people. And the math behind that is communication pathways, which most Agile coaches are familiar with. So what I got to learn working with the leadership team at Amazon was absolutely true at Tesla and SpaceX as well. So the car is split into these parallel executable modules like body in white and heat pump and interior package and battery pack and drive module. And these teams do continuous release all the time. About once every 3 hours, there's an update. And other hardware companies seem to have a challenge with this because they seem to want to track product release by the year. Like every car we made in 2021 had this configuration. Well, what are you still tracking your inventory on paper? How does Google track people, or LinkedIn or Facebook or all the world's governments? They have a digital twin of people. And that model, that digital twin of all of us with our names, whether we currently have a Facebook account or a LinkedIn account or not, says who they think our friends are, what apps do they think we have installed now, what kind of laptop and phone do they think we have now, what kind of laptop and phone do they think we had before, and what apps were installed on them then, and when were our friends then. So they have this digital twin of us. Well, when every single product you make is potentially unique, that is how you have to manage your inventory. Every single car Tesla makes is a GUID, and there's a continuum of what configuration that car has, which heat pump it has, which bolts are installed where, what type of glue was used, who was on shift when it was made. You have to, or else you'd be restricting innovation and speed of innovation. And that's an IT project. And that's an IT project most other major companies haven't taken on yet. So that's part of why they don't feel comfortable with continuous development, continuous release, and continuous integration yet. But Tesla is a digital native. They came right out of Silicon Valley. So of course they use relational databases to inventory their product. So of course they're fully comfortable making changes in real time. If they had to execute a recall of an adhesive, they do know which cars have it and which don't, even though that could have been deployed on or off anytime at any different manufacturing facility. Now you do have these company as a service teams, things like a coffee team. Truly, there are baristas and baristas all across the Musk companies, and it's their job to try to make world-class coffee, Viennese style coffee, which I love, more sour with sugar and cream usually, Australia barista coffee, chuggable, black, American cafe style coffee, a proper doppio espresso, etc. They really try to do world coffee, and they do actually excellent job. There's a facilities team to make sure if you're supposed to have access to the internet or the facility, you do in less than 5 minutes. And if you shouldn't, you don't in less than 5 minutes. In fact, the SLA is even better than that. The service level agreement is even better than that. There's a gourmet team to serve hot food, and they try to make it Michelin 3-star quality every 3 hours, 24 hours a day, 7 days a week. And I believe the coffee and gourmet team are necessary when you're working 12-hour shifts, because it uses a lot of energy. You're working like a professional athlete. You treat yourself like a marathoner or a boxer or a skier who's really trying to be world class. But when you have a world-class support team, like the gourmet team and the coffee team, it's much more reasonable. It's much more possible. And it's a lot of fun. I've never had as much fun at work as when I did working at Tesla. And there is a funding team of which Elon is part, and it's their job to make sure everyone has enough money. From the minute you're empowered, from the minute you're hired, you're empowered. You can buy a robot, you can buy land, you could buy a truck from the minute you are hired. And it's the funding team's job to make sure there's a pool of money you can pull from. Now, if you abuse that power, you will be asked to leave the company, but that's it. There's a 4-page guide when you're hired saying, basically it says you can do anything you want, is pretty much what it says. But it says if you do really bad things, we will ask you to leave. And it says we're not even going to list all the bad things because we trust you and there are too many bad things to list. So just please don't do them. And that is the company culture. And there are tens of thousands of people, and it is now the wealthiest car company in the world and increasing in value rapidly. So apparently it works. It's a lot like open space. If you ran a company with the rules of open space and had a lot of industrial robots, it would basically be Tesla or SpaceX. Working with Elon, a lot of people don't seem to understand this part. So if I got to share something, I would want to try to explain this. Elon says, if something is physically possible, not only is someone doing it, but there's also an award show. This sounds like a joke, and it is, but it's also the product owner mindset in a company like this. There is no marketing department. There is no competitive analysis department to say, well, Daimler is doing this, so we need to do this. Or Toyota is doing this, so we need to do this. There's none of that. They don't do that at all. And the reason why is everyone has very clear encouragement to approach the limits of the laws of physics. So it's not, should the car be safer? Toyota has this safety technology. Honda has this safety technology. Saab has this safety technology. Well, now they're owned by Geely, but etc. Is it physically possible to be safer? Well, then do it. And there's no range benchmarking competition at all. Well, the Porsche Taycan has this range. We need to increase our range. There's none of that. They don't need to. It's simply, is it physically possible to have more battery density? Okay, well then do it. This is what keeps people so excited. If someone says, I have an idea to make the product better, the answer is only yes, ever and immediately. In fact, it's why didn't you start already and how can I help you? That mindset, that culture makes it such an invigorating place to work. And it also means there's no waiting. You're never waiting on approval because you know you have it and you know what the goal is. So you just run as quickly as you sustainably can for your 12-hour shift, and then you overlap with the next. The advantage, by the way, of the highly controversial 12-hour shifts is that idea of group ownership that the XP community has been celebrating since the 80s. It works in hardware too. And that means you do truly hand off all the time. You can't own anything if you want round the clock, round the world development, especially if you want to work in a swarm or a mob, even during your time zone. The 12-hour shifts enforce that because nothing stops when you walk out of the building, well, or sign off or whatever. I worked physically on site, but I worked remote too. This, of course, changes how production works. It means your integration has got to be automated. So in less than 5 seconds, you know if all these new parts work together. That means all the production machinery has flexible hands, and it means the parts themselves have known stable interfaces. It's like an API. So the door has basically an API, an application programming interface on the door, so that the other teams that are going to connect to the door know as long as the API doesn't change, as long as the interface doesn't change, we can change it anytime. Automation in software and hardware and management with test in the loop is in fact the answer. Humans are for creative problem solving. Automation is for everything else. I want to try to show how new product introduction works and then ask any questions or comments from anyone and have, I hope, a dialogue. Now, I just drew this morning and last night. This is fresh. We'll see if it's understandable. I'll do my very best. In the factory, you have parts. So sheets of metal, circuit boards, tubes of glue, pulled on carts and delivered by robots to areas of the factory. And so now you have these groups of partially manufactured things, cars, rockets, electronics, and you do a sequence of value-added steps, like connect a heat pump, glue a garnish trim in, and install some rivets. You have a self-organizing team that monitors this. It's largely robotic, and they feed things and get the machines unstuck and reprogram the machines. There's a definition of ready, so you check your supply, because your supply is changing continuously. I mean, remember, this is not a waterfall. So the parts coming in are different every few minutes, and you've never seen them before. But as long as they meet your definition of ready, you know they're going to integrate. So you check your definition of ready, which is largely automated. You have red lights, green lights on, does it meet the definition of ready, even though you've never seen these parts before. And there's a corresponding definition of done to make sure you're likely to meet the next piece in the flow's definition of ready. And again, they've never seen the parts you're about to send them before. But as long as it meets the definition of done, the flow will work. So how do we do new product introduction? We install a router. This is exactly the way excellent software development is done. We install a router, and a router in a place like Tesla is a tablet to select where these parts are going to go. And robotic carts or robotic tracks fork exactly one car off. So exactly one car is forked off programmatically. This is all controlled by software. And if we ever do something to the inputs, we do the same thing to the output. So that means there's a router by our definition of done too, of our lean cell, this operation, this agile cell. And that router could take in a car. And then we have a small co-located cross-functional self-organizing team whose job it is to try really different stuff on exactly one car. They forked off one car and they might develop a different heat pump. If vendors are fast enough, they'll use some vendors, but most of the time they have to make everything in-house just to be fast enough. So they have a lot of 3D printing in production, a lot of fabrication, machining on site. So working in Tesla, you're cross-trained in a lot of fabrication skills and a lot of robotic skills and a lot of programming skills. And you make a new thing, and if it meets the definition of done, and so you pass unit test, automated unit tests, you branch exactly one car back in. So out of 1,000 cars made, there'll be a mix of different kinds of cars with different capabilities. It's not like every car from this time forward has this configuration. It's nothing like that. It's a mix. And you have a varied amount as this, we call it a pilot line, the second line making the new thing, as they ramp up capacity. This is what Elon talks about when he talks about the production ramp. So you ramp up capacity of this new group while the previous group, the previous best working version, is still in volume. And the routers dynamically balance that until you're at 100% on the pilot line, and the pilot line ceases to be called the pilot line. It's now the line. And the other place is now dismantled to try different experiments, maybe for an entire different product, because this is not linear. These cells are scattered all around. Trying to make this linear, single one-piece continuous flow would be way too slow, because you'd have a ripple effect across the entire line. So you have these basically independent tiny factories, agile cells with definitions of done, definitions of ready, and routers. And then you have people pushing carts and robots delivering pragmatically all throughout. And it actually looks just like the operation inside a living cell in the human body. With that agile new product introduction, I would love to hear questions and comments from all over the world.